which type of water was used. Was it natural grape water or was it added water? And to a lesser extent, of course, the sugar concentration in the original must. So, detection of illegal watering of grape must. Official method. There is an official method in the European Union which is used for detection of illegal watering in wine. It is based on an analysis of stable isotope of oxygen directed from wine, and it is an equilibration method. They use gas bench, and what is the problem here? Because to the right you have example of European isotopic wine data bank. So as you can see, all these spots are different wines. So each wine will have, according to his geographical location, climatic conditions, will have specific delta 18O value in wine water. So if you want to detect illegal watering, you have to compare the analyzed samples, the results from the analyzed sample with the data bank. So let's say, for example, we take this north red spot, this one. We add water. This, because local waters, surface waters has more negative delta 18O value, this value will be more negative. But compared to isotopic profile of that water, it may be fall here. It will be still positive, not negative in minus. So we cannot confirm that water is added if we don't compare it to that specific sample from the wine data bank. On the other hand, EIM RMS utilizes information obtained from wine ethanol. If water is added, ethylene delta D value would be changed compared to authentic sample and out of the reference zone for natural range for grape alcohol. This means that if water is added and our analyzed sample is a known sample, which means that we don't have it in our isotopic wine data bank, it will be determined as illegal production practice, because watering a wine and chaptalization are forbidden practices as additional water or additional sugar. And if we have our information for specific wine in our isotopic wine data bank, then we will compare ethylene delta D values with oxygen delta values, and we will determine if sugar or water is added, or both. So, further, to summarize this information till now, if we take into consideration the enzymatic peculiarities, the grape must is naturally closed biochemical system, climatic conditions and geographical location, the fact that the hydrogen atoms of grape water are equilibrated with hydrogen atoms from the hydroxide of sugar, we can conclude that deviations in the relative ratios of hydrogen stable isotopes at the methylene site of ethanol will have significant but internal character. Specific wine ethanol will have a specific delta D value of non-exchangeable hydrogen stable isotope relevant to the area of origin. And also, our data suggest that variations induced by local climate and geographical location are not large enough to override the physiological processes and the information contained in non-exchangeable hydrogen. So this means that if fermentation medium is genuine, then those delta D values will be in very narrow range from approximately minus 205 to minus 250 per mils. And in case where additional sugar in wine comes from sugar beet or sugar or corn, those ethylene delta D values will be much more negative compared to ethanol which originates from natural grape. And this is why EIM RMS is so powerful. So, further, overview of the present quality control of wine. Based on sniff NMR methodology, European Commission has founded BEVOS, This is a European wine office for wine, alcohol, and spirit drinks, and it is located at Institute for Health and Consumer Protection, and a network of national reference laboratories throughout European Union to prepare European isotopic wine data banks used to guarantee the geographical origin and authenticity of all European wines with designated origin. So this is the feedback from for Sniff NMR. As stated by Claude Guillaume, who is the team leader of Palermo and his associates, and it was presented in Scientific and Technical Report, which was published under the title Analysis and Characterization of Alcoholic Products in Joint Research Center Bulletin in 2008. I will quote this one. With this approach, the addition of beet sugar, ethanol, to wine with high methyl deuterium ratio value of 105 ppm will be detected only if its proportion is superior to 50%. If ethanol added comes from grain, it will be detected only if its proportion is higher than 70%. So we can see this in the table. If addition of beet sugar is more than 35, cane 50%, grain 70%, potato 40, fruits 100, synthetic ethanol 50, this means that this adulterated ethanol will be out of the range for natural grape ethanol. And here we have a graphical presentation of Sniff NMR result. So you can see that beet sugar and cane and grape sugar those clusters are very close to each other, meaning that it implies that for determination of botanical origin, it has to be compared to an authentic sample. So on the other hand, we have EIM RMS. Now you can see that those clusters are pushed from each other, and the difference is not expressed in ppms but in promilles. The difference is 7,000 times better than with Sniff NMR. The difference between mean values of those clusters is approximately 70 promilles, and the free distance between clusters is approximately 40 promilles. And this opens the possibility of detecting of adulteration in known and unknown samples. Because if something is added, it will be out of the cluster and detected visually. So if we take comparison of accuracy between two methods for dry characterization, for Sniff NMR with wine with mean value 102 ppm, for known samples, detection from above 6% can be detected. For known samples with accuracy 100%, above 37.9%. And EIM, same principle, we can detect 3.7% for known samples, and for unknown samples above 10.7%, meaning that this value would be out of the reference zone. So comparison techniques, what we can do, determination of botanical origin by measuring addition of water and sugar to known and unknown samples, determination of geographical origin, also ability to uncover counterfeit wine, more accurate analysis, low cost analysis, short time analysis, we take only 2 minutes for analysis. Okay, it's a patented method, and only disadvantage in this moment is that currently sample preparation is performed offline, but we are working on continuous flow setup. And this is at the end. After this, we have just two slides more. So this is a hypothetical preview. So as I said, by comparison ethylene delta D values with oxygen in wine water, we have two choices. We have two cases, sorry. Addition of sugar, meaning that oxygen value would be the same, stay the same, but ethylene delta D value would be changed. And the second case, if is the adulteration with addition of sugar and water, then both those isotopic species would be changed and be monitored via RMS. So conclusions, we have shown that authentic grape ethanol expresses specific and unique ethylene delta D value for each wine ethanol. RMS method presented here provides high precision and accuracy and has potential for the determination of authenticity of geographical origin wines using TCEA RMS. So if wine was was prepared by using illegal production practices, those equilibriums between non-exchangeable stable isotopes in wine, water, and ethanol will be changed, and we can monitor them. shows better repeatability and more accurate than sniff LMR. It can be used on widely deployed RMS technology all over the world, and the repeatability and reproducibility will be improved even further with utilizing continuous flow setup. And since the EIM RMS method shows much larger free space between clusters of ethylene delta D value for beet sugar and grape than sniff LMR, it is capable of detecting illegal production practices even for wine with designated origin. So at the end, more accurate results than in less than 2 minutes, significant cost savings, more many samples can be analyzed per day, and it means 1:2 for all topic analysis of wine. So thank you very much for your
very interesting presentation. Are there questions? Otherwise, I have one, which is, I think that you have to take into consideration